Hey guys, my name is Frank, and this is the Python Programming Video Log. In today's video, I'm going to show you how to do circle-on-circle collision response, so stay tuned to find out how it's done. Let's take a look at the example program and see what's actually going on to get these two circles to collide, and then we'll take a look at the collision response code that makes everything work. So I have a blue and a yellow circle, and the white line between them represents the distance between their center points in pixels. So the length of that white line is going to be represented here by that number, and the sum of their collective radii is going to be represented here, and it's currently 100 because each one of my circles is 100 pixels in diameter, and half of a diameter is a radius, and if the radius is 50 for both circles, that added together is going to be 100. So at any point in time, if the length of my white line drops below or equal to the sum of their radii, I'm going to have a collision. So actually right here, it's reading the length is just 1 pixel over. That's because collision is happening, and I'm placing the circle just outside, 1 pixel outside of collision, so that's why the length is 1 pixel more than the sum of the radius. But for this collision to happen, that length is going to have to be equal to 100 pixels or less. So as you can see, it's just pushing the circle back out of my collision, and it doesn't matter what the radius is of these circles, it's gonna resolve collision every time. So come up here, refresh so these get back to normal size. Now let's come over here and take a look at the source code. So here is my circle class. All it is an x and y point for the center, or just an x and y value for the point at the center of the circle, and a radius that's going to be half of our diameter. And I'm going to come down here, take a look at the collide circle function. I have a video on this, go watch it. This is going to do collision detection between circles, but this is important to understand, so I'm just going to recap it a little bit. We're going to calculate the distance of our line, that white line, with x and y distance, and we're going to get the radii sum. We're going to test to see if the square of the distance is less than or equal to the sum of the radii, and if it is, we know, or the square of the sum of the radii, and if it is, we know that we have a collision, so we return true. So in the game loop that is constantly running to check to see if our circles are overlapping, this code is going to run if a collision is detected. If this function returns true, then I'm going to go ahead and I'm going to call this function, which is resolve circle collision. So it's also going to take two parameters, circle 1 and circle 2. That's going to be my yellow and blue circles. And I'm going to do some of the same code, and you're going to think to yourself, well, that's kind of redundant. Why not just lump it into one function? Well, because I want to explain everything to you guys as clearly as possible, so this is all the code that you will need to do this. It can be summed or lumped up into one function to handle collision detection and response, but for the sake of this example, I'm just going to have two separate functions that have a little bit of redundant code. So like I did for collision detection, I'm going to get the x and y distance between my center points. So I'm going to have circle1.x minus circle2.x, circle1.y minus circle2.y, and that's just going to be the distance between my two center points, or the length of my white line on the x and y axes, or axes respectively, axes. Listen to me talking here. And then I have the radii sum, and that's just going to be the sum of the two radii of my circle. So circle1.radius plus circle2.radius. And now we're going to get into collision response area of this code. So length is going to literally be the length of my white line here in pixels. So to get length, I'm going to have distance x times distance x. I'm squaring distance x. And I'm going to add the square of distance y, and I'm going to lump that into math.square root. I'm going to put that inside of a math.square root function call, and that's going to give me the square root of the square of my distance, and that's literally going to give me the length in pixels of this white line. So right now, if you look up here at this value, my white line is 180 pixels long. If I come here, it's 101 pixels long, as you see things drawn on the screen. So the reason that I have this little or 1 here is because if this length is equal to 0 for any reason, and the only reason it would be is if this blue circle was exactly, if its center point was exactly equal to the center point of the yellow circle, and I could probably get that to work if I put my mouse right over the center, but it's hard to find the center with a mouse pointer. If length were equal to 0, then when I'm defining unit x and unit y down here, I'm going to have division by 0, and I can't have that or it's going to create an error. So if at any point my center points are perfectly overlapped and length is equal to 0, so if this code here is equal to 0, it's going to say make it 1 instead, and that's going to save me from having that error. So far I've calculated the distance on the x and y axes respectively, calculated the radii sum, calculated the length in pixels of my white line, or the distance between the two center points of my circles, and now I'm going to calculate the unit x and unit y values. So all these are going to be, let's say I have a line here, the white line, and it's 172 pixels or 170 pixels long right now. Distance x is going to be just the distance between my two center points on the x-axis. Distance y is going to be the distance between my two center points on the y-axis, and length is going to be 170 pixels. So to get unit x, I just take whatever the distance is between center points on the x-axis and divide it by 170. Unit y is going to be whatever the y distance between center points is divided by 170. So that's going to give me my unit x and unit y, and what that's going to allow me to do is get the direction on the x-axis and the direction on the y-axis that I need to multiply the radii sum by to place my circle 2, or I think circle 2, my circle 1, which is the blue circle, I guess. It's going to give me what I need to place circle 1 in the correct location after I do collision. So if you take a look here, what's happening is I think circle 1 is the blue circle, circle 2 is the yellow circle. So I'm going to set circle 1's x position after we have a collision and we're resolving it. I'm going to set it directly equal to circle 2.x. So if this were the only bit to run, what would happen is the center point of the blue circle would be set directly equal to the center point of the yellow circle. So that's where we are. Then I'm going to add the radii sum plus 1 multiplied by the unit x and unit y position. So radii sum is going to be the distance, the sum of our two radii, the radii of each one of our circles. So if you look right here, radii sum is going to be 100 pixels. So my white line right now is 101 pixels, and that's because I'm doing radii sum plus 1. If I were to do radii sum not plus 1, save. Just remember, now I have radii sum plus 1, and that's going to give me 101 pixels right there. If I refresh, I just got rid of that plus 1, so now it's just going to be 100. And as you can see, they're a little bit closer together. It's still technically colliding because their edges are still technically colliding. So this bit of code right here, getting the unit x and y, is just going to give me a very, very tiny directional vector, which I then multiply by the length that I want to move my circle 1 by. So I'm just setting circle 1 to equal circle 2's position, and I'm going to add the length I want to move it by, which is going to be the radii sum, plus 1 ideally. I'm going to multiply it by the direction of that unit vector, so unit x and unit y, and that's going to be circle resolution. So let me just add in my plus 1s here one more time and show you what that looks like. So now, as you can see, they're kind of overlapping a little too much, and that's without the plus 1. If I come in here and I save what I just did, and I come up here and refresh, that's going to offset things by just a little bit more, so they're literally just pushed out of collision with each other by 1 extra pixel. So that's how you do collision response. Definitely take a look at the source code, and I have that linked in the video description. Now you know how to do circle-on-circle collision response. If you have any questions, please leave them in the comments section below, and if you learned something, please give this video a like. Be sure to subscribe to my channel for more videos, and I'll see you guys next time.